Kirumbi Engineering Skills Academy. We are available at Dar es Salaam, Tanzania, East Africa. You may contact with us through phone number +255 737 72 1910, or you may contact again with +255 85 74 85. Email us with Kirumbi Engineering Skills at gmail.com. Website Kirumbi Engineering Academy at ac.tz. Now consider the beam which is loaded as you see. Now today we are continuing with the example for the moment distribution method. Consider the loaded beam like as you see, in which it is loaded with point load 80 kN and the uniform distributed load 16 kN per meter, which has the length as you see, the point which is 3 meter from support A and 2 meter from support A to B. Also from support B to C has got about 4 meter. Now on loading we assume EI as a constant. Also as we assume, once we assume the I as a unit factor, now let's consider the moment distribution method as follows. The first procedure, as you see, we find the stiffness factor, which is K, in which K it is a function of I and L, as you see, where from the support, as you see, from support A to B and support B to C. Once you calculate the stiffness factor K, A to B, stiffness factor K AB should be equal to stiffness factor KBA, which is the ratio of the I it is a unit, and the L it is the summation of 3 meter and 2 meter, as you see. Now this you get your factor there, and the division of 1 to 5 we have an average of 0.2. Now the same way once you want to calculate the another stiffness from support B to support C, which is a fixed support, as you see, which is a uniform distributed load there. Now the length is about 4 meter from support B to C. Also, as you see, support B it has pin support, and support C it is fixed support. Now once we take for the consideration from the support the stiffness factor KBC should be equal to stiffness factor to CB, which is the ratio of I over L. You get about 0.25. Now since the distribution factor we want to calculate the distribution factor for the moment distribution. Now we take the following consideration. Now the stiffness factor, as you see, distribution factor, which is df, should be equal to the value of k over the summation of the k at the support. So it depends on the support. It is prolonged with how much support. If it is two connected beams, for example, from single support, you should take the summation of the left and right support. So now distribution factor from AB is equal to 0, in which this is for the fixed support. Now once it is fixed support, the distribution factor is always 0. Now why it is fixed support means this fixed support, it is here. Now this here distribution factor is equal to 0. The same applied once you consider here the distribution factor is equal to 0, which is a fixed support. So now upon consideration on that one, now we got the distribution factor at the support AB should be equal to 0, in which this is the distribution factor for the left hand side. Now the same applied the deflection factor BA. As we said, it is the ratio of KBA over the summation of the ratio of K at the support B. So now this one should be the same as you sum the K at BA, as we calculate there, is about 0.20, and the summation of left 0.2 plus the summation of right 0.25. So on calculation it is about 0.444. Now this will be the distribution factor between the member BA. So the same applied as you find for the right hand, meaning the beam from support B to C. The deflection factor should be the function of ratio of KBC over summation of the ratio at support B. So the same way as we calculated from above, we repeat the same procedure to the right hand side. So what can we get? Now from there we can calculate the right hand KBC is about 0.25 over the summation of the K at support B. Now on calculation you can get the value is about 0.556. So also, as we said, for the fixed support, the value for DF, distribution factor, is always 0. So for the right hand side, the same support is fixed, so the deflection factor between C to B shall be equal to 0, as you see here. So this is the way how we can calculate the distribution factor before we proceed. Now as we proceed, you can start for the support of the member AB. Now the member AB is the left one, which is this one. We consider this support from A to B. So we fix there, as you see, we fix up this point. So we consider the first, if we take this one to be restrained, so this will be fixed from A to B, as you see, like this way. So that one will be the consideration from the support. Now let's consider when we consider we mean as we consider for the support between A and B, we take the ratio from the point load. If we take for the point load here, as you see, the point load is concentrated load is about 80 kilonewton there. Now from support A to the point load is about 3 meter. The same applied from the point load to the support B is about 2.2 meters. So as you take for the moment, which is going this way, and the left one which is going this way, now the fixed end moment should be calculated. So on calculating, the moment should be in terms of the fixed end moment between A to B. It is the ratio between the distance from support A, which is A, and the support, the length from the concentrated load to support B, which is B. It is a function of a negative here, times the value of P here, times the support distance A, times the multiple of AB square over the ratio of the length. The length is the distance between the two support, which is marked as L. So once you take the square of that one ratio, you get your value for the fixed end support from left and right. So if we take from left, this one, the consideration shall be the fixed end moment between A to B, which is a negative value, as we said. The same applied once you want to calculate from left, upon entering the value for P is 80 kilonewton, 83 meter. Take the square root of B and the ratio of L square. So once you calculate, you got the negative 38.4 kilonewton meter. The same applied once you consider from the fixed end moment between B to A, which is B the positive value, the opposite one. Now here the P times the square of the A, and the B is now not square as it is for the previous equation. So divide the ratio of the square of the length, as you see there. Now upon substitution, once you substitute the value there, will be the same value, but it is a positive one, which is about a positive 57.6 kilonewton per meter. And now this one will be the consideration for the member, as we say, the fixed one. Once you fix the member, this is considered, it is a fixed one from B and A with a uniform concentrated load as a point load, which is between this length, and the total length should be the summation of this two value, which is the value of 3 meter plus 2 meter, which is a 5 length between A and B. So once you calculate the fixed end moment, as I said there, you can get the fixed end moment from left here this way, and the light there, and the light layer this way and this way. This you get the fixed end moment between A to B and the fixed end moment between B to A. Once you consider the point B is hinged and it is a fixed one, once you hinge the point from A to B, it means here point it is restrained. So once you restrain, you can get the value the fixed end moment from left and from right, like this one. So now we consider now the fixed end moment now to the point, the coming point, which is point B and point C. Now the same way, once you take these 2 points, shall be a fixed one as it was in the left, but this one has got the uniform distributed load. Now should be like this one, and this is point C, this is point C, and this is point B. So the same consideration, the value here is about 16 kilonewton. Now let's proceed. Now once we proceed, what happened? On proceeding, once we take the support between B and C, so as I said, will be like this one. The distance between B and C, it is 4 meters, as we said. Now this one, it is fixed with this one and this one, so it is fixed support. Now the ratio of the moment between B and C, it is accompanied by a negative. It is accompanied by a negative. It is accompanied by a negative WL square over 12. Now this is the general formula from the fixed end moment for the uniform distributed load. Now upon entering the value, now once you substitute the value, of W, which is 16 kilonewton per meter, and once you substitute the ratio of the length, the square, and divided by 12, the value now shall be calculated. And once you calculate here, you shall get the value, this value here. Once you calculate the value, you shall get this value here. It is a positive for the one side and a negative for the another side. So between CB, it is a positive value, and between BC, it is a negative value. So you can calculate there the value, it is equal and opposite. BC should be a negative and CB should be a positive. Now that is be equal and opposite. Upon calculation, now you can get your value. Once you can get your value, you can start to calculate your table. Now your table, it is a function of joint A, joint B, joint C. Now these are obtained from the previous support. As you see, the moment distribution, it is a function of your joint, which is your joint is what we see. It is joint A, joint B, and joint C here. Now should be distributed the moment between the support to the member. So we can consider the three joint A, but if you see here joint B, it is a function of length between AB and the function of the length between BC. Joint C, it is single joint. It is a function of only one length between B and C, and the same joint A, it is a function between the lengths between A and B. Was joint B, it is multiple. Joint this one and this one has got two supported from one point. So now let's proceed there. As you see, now our table should be considered for the joint. Now the joint is the function of joint A. Joint B has got BA and BC, Joint C is only has got the member CB, and joint A, as we said, has got only the member AB. Now, before I proceed, let's have something which is very important. Now, this one is the so-called first step. The first step, we consider the so-called distribution moment. The distribution moment, it is a function of dF factor times the fixed end moment. Now, suppose we wanted to consider the distribution moment for the unsupported. Now, what we say? The fixed end moment, let's consider the value for the joint, the value for the joint. Now, the fixed end moment at support A, as we say, distribution factor at support A, which is a fixed support, we say the distribution factor is always always 0 for the fixed support, and also for the right hand, the distribution factor at support C, it is 0 because it is fixed support. But support B, it is distribute two members, which is member BA from the left and the member BC to the right. Now, as we calculated the value of K, we got 0.44 for the left, and we got 0.556 for the right. So what you can go now, the fixed end moment, as we calculated, the left one, we got moment between AB, which is a negative 38.4, and once we calculated for the right, we got this one. This is the moment between BA. Now, for the uniform distributed load, we got the negative from left and the positive from right. So this is the moment distribution for the fixed end moment between member BC and member CB. So what happened? So always we must to start to calculate the so we call if you add this one and you add also this one, the summation of 57.6 plus negative 21.6, you shall go to the excess value. Now means the value at support B, it is unbalanced moment. Now the value here is the one which is excess. Now in order to balance, should be added the negative or the opposite value for the moment from this support. So the difference between this and this one is a positive value. So vice versa of the value should be a negative one. So now let's look at the simple arithmetic which we did here. Now for the unbalanced moment, if you take 57.6, you add the negative moment, which is 21. This one, you have the excess moment about 36.2. Now this excess moment, in order to balance at that joint B, should be the opposite value of the moment, so as you can balance at that joint. So the excess, which is positive 36.27, should be balanced with a negative value of the same moment in order the joint to be balanced. So at equilibriums, we should have an excess of a negative opposite moment of about 36.27 kilonewton per meter. So take this, the excess of the moment, which is negative, times the ratio of the distribution moment. For the lefty, the ratio is about 0.444. Now times the value for a negative 36.27. So once you times the value, the difference balanced moment between member BA should be a negative value about 16 negative negative 16.103 kilonewton per meter. So what will happen for the light one? The light one, you take the value for the distribution moment for the member light BC, you times the unbalanced moment in order to have the equilibriums, which is about negative 36.27. So once you calculate also for the light one, you shall go to the value which is about negative 20.164. Now this value now should be carried over moment, and this is the second step. So what will happen if we have your member which is say fixed like this one, which has a certain fix there, and your member should be distributed a certain moment from left, which is moment ij, and should be distributed also the moment from right, which is the moment between ji. Now in order this moment from this left to distribute to right should be the half, of moment from this side. The same way, if you want to distribute this moment here from right to left, should be distributed to the member by half of the moment from right one. So upon that theory, which is called the carryover moment, and this is the second step on distribution. So this moment from this side you distribute it to that way, and this moment from this side you distribute it to another way. It is a close multiplication. A vice versa moment should be taken. So what will happen? For example, the moment from light, it is this one. So this one times by a half should be distributed to left one. The same way, if you take the above moment, which is a right one. Now the above moment, if you take it was about 16. So this also should be times by a half to distribute it to this way. So what happened? Now upon calculation, we shall have a certain amount, which is this one calculated. Now negative 16.103 times a half should be a negative 8.05 to be transferred or carried over to a joint R, in which this one, the moment is from left, now transferred to joint R, which is a left one. So the same transferred to that one joint should be carried over. That's what we call the carryover moment. The same applied. Once you take the light moment, which is this one moment, about 20.164 times a half, which the value should be equivalent to a negative 10.082 kilonewton to be transferred to joint C. Now it is said the carryover moment from left to joint C, from joint B to joint C. Now upon distribution, what will be to our table? Now once you have that one, come back to our table. Now if you see here, after having the moment distribution factor, which is we take the ratio between this one, we times the balanced moment after summation of the two value, the two value of this one, the opposite one, which is unbalanced moment, times with its ratio here, this ratio here, sorry, times with its ratio here. Now the ratio with the summation of a negative unbalanced here, we got about 10, this value here, and we got about 16, this value here. And the ratio also for the unbalanced with this ratio here, we got about negative 20.160 something there. So this value should be carried, we say the carryover moment. Now the carryover moment, we say this is the fixed moment. Now it is carried half to the left, and this one should be also carried a half to the right. Now because 0 times a half, it is a 0, so here we shall have a 0 value. Sorry, this one you shall have a 0 value here. Let's see, this one should be a 0 value. Now also this one, negative 16 here, times a half, we shall get a negative 8.05. So now it means carried factor, this one should be distributed to joint A. The same to the right, the carried factor, this one a half, should be distributed to joint C, and this one should be distributed to joint B. So because this is 0, here should come to 0, because it is distributed 0 to the half. Now this one 20 should be halfway, should go to 10, and this one 16 halfway should go to 8 point something. So the so we call the carryover moment should be a half, vice versa, so transferred to the joint. Now we can get this value here, and this here 0, this is 0, this is negative 10. Now if you see this value, you can times with also the same the so we call the distribution factor as we did to this way. So once you take a 0 times by this one, you can get the value to this one. The same applied if you take this one if you times by 0 here, you can get the value this one, and this one if you times by 0 here, as a value you get this one, and this one if you times by 0 here, by 10, the value get 0. So if you can see all these value come to an end, cannot continue so far, because the moment now it is going to 0, so can't proceed more than there. So what you can do, because the moment distributed, it is going to balance. So if it is balanced, now you take the arithmetic of this value, sorry, you take the arithmetic of this value, you take the first value of the fixed end moment, this one, you sum with the second value here, you sum with 0, you sum to this one. So the value you got is this one, which is a negative 46, negative 46.452 kilonewton meter. So the same way, if you sum for the second column, which is this moment, this moment, this moment, and this moment, you can get a negative 41 point something. You sum for the another column, which is this one moment, and this one moment, this one moment, and this one moment. You can have the opposite one, which is also 41. You take this moment, this is 0, this negative, this is 0, you have this value. So what happened? So upon arithmetic, you shall see the value, the actual value which you get from the support 1 you get negative 46.452. From the support BA you get positive 41.497, and from the another support it is the vice versa of this one to this one, because the same support but difference, the counterclockwise moment is appeared. So also if you go to this support, see the value, it is positive moment. So once you evaluate your value, it means your value now is this one for another support. So from there you can draw your bending moment, or as a free body diagram, or the shear. You can calculate from the restrained value, because now the value from each support you have there as it is. So that's the way how simply you can calculate your value. Now in conclusion, from the table, as we said there, this was as we said, this was the second value, which the second distribution, which all the value at the moment distribution there you get 0, so which is approaching to 0, so the moment is already distributed. Now upon arithmetic, as we said, the joint A, your value is about negative 46.42 kilonewton per meter, and the joint B is about that one. Means if you can summarize the support moment, you can get there like as we see here, joint A value, joint B value, and this joint B has got a vice versa, and the joint C, it is a positive value. So in that way you can have your moment, and then through your moment you can calculate the support due to the moment, meaning by using the principle of equilibriums. Means taking the moment at point A, you can get the reaction at point B as its trend, and the taking moment at point B, you can get the reaction at point A, or the summation of the vertical load is equal to 0 at equilibriums. You can have two equations, which is simultaneous equation, in which you can calculate the reaction at A, and then you can substitute the value to calculate the reaction at B. The same applied once you take the member between BC, taking a moment at point B, you can have the reaction at point C, and taking a moment at point C, you can have reaction at point B, or the vice versa. Once you calculate, take the equilibrium equation at the vertical, the summation of load, or the summation of force in the y axis is equal to 0. So at equilibrium you can have two simultaneous equation which has got the unknown value of reaction at B and C, or the unknown value at reaction between A and B. On substituting each and another through the moment and the force you have, so you can have your reaction, and hence you can have your shear force at the support, and you can draw your bending moment diagram. The same applied the shear force diagram to both the value at the value at the support as it is in the previous question given. Means as I said here, at equilibriums, once you take it at equilibriums, because this value you have and this value you have, taking moment at this point you can get reaction here, and taking moment at this point you can have reaction there. So or at equilibriums, the reaction RA and the reaction RB should be equal to the load applied at the center. So the same way, once you go to another restrained equation here, at this restrained equation, as I said, because you have already the moment here and the moment here. So taking moment at this point, you can have the reaction at this point. Also taking moment at this point, you can have reaction at this point. Or the summation of the reaction at A and the reaction at B should be equal to balancing a concentrated load 80 kN per meter. So you can have a known two equation. One equation is through taking moment, another equation is summation of vertical force at equilibrium. So solving the simultaneous equation, you can have the reaction at A and the reaction at B. So you can have your shear at this support, and hence you can draw the bending moment diagram and the shear force diagram as it is in the general given force with the fixed end supported to this 2 point there. So now it can be easy to have your free body diagram and the all value for the bending moment, for the maximum bending moment, and the maximum reaction and the shear force. Now we can proceed more. More tutorial and more theory for the moment distribution method oncoming tutorial, and follow us in our website Kirumbi Engineering Academy.ac.tz. You can have more tutorial for the online training. Welcome. We are welcome a lot. We welcome a lot. Thank you. We are welcome a lot for you. We thank you a lot for following our tutorial. Email us with Kirumbi Engineering Skills at gmail.com. Website Kirumbi Engineering Academy at ac.tz.